Hello, everyone, and welcome back to this lesson. Now, in this session, we're going to explore one of the most important ideas in statistics, the Central Limit Theorem, or CLT. We're going to dive deeper into this. Now, the Central Limit Theorem is a fundamental principle, again, that explains why sampling occurs and how sampling works, and why we can make predictions about entire populations based on small samples. Now, in this lesson, we'll cover two main topics: the importance of the central limit theorem in statistics and why it's one of the most powerful concepts in data analysis, the implications for sampling, how it helps us draw conclusions about populations using sample data, and then by the end of this lesson, you'll be able to understand why central limit theorem is the foundation for many statistical methods and how it applies to biostatistics. Okay, let's get started. Now, first, let's define again what central limit theorem actually says. The central limit theorem states that if we take many random samples from a population and calculate their means, those means will form a normal distribution, regardless of the original population's shape. Okay, that's important because it allows us to use the normal distribution for making predictions, even when the underlying data isn't normal. Now, that's great news. Now, why is the central limit theorem important? It's important because it helps us to make these accurate estimates about populations even when we don't have access to the entire population. The reason this works is because even if the original data is skewed or not normal, the distribution of sample means will be normal if we take enough samples. The other thing is that the more samples we take, or the larger our sample size, the closer the sample mean will be closer to the true population mean. And also, since sample means follow a normal distribution, we can apply statistical techniques like confidence intervals and hypothesis tests or hypothesis testing with confidence. So as an example, let's say we're studying cholesterol levels again in a population. The cholesterol levels of all individuals might be skewed, but if we take multiple random samples and calculate their mean, those means will form a normal distribution, which allows us to make reliable predictions. Now that we understand why the central limit theorem is important, let's talk about its impact on sampling in research and biostatistics. Now, since sample means follow a normal distribution, we can use samples to make predictions about entire population. Now, this is why central limit theorem is the foundation of inferential statistics. So sampling distributions become normal. No matter what shape the original data has, the distribution of sample means will be normal if the sample size is large enough. Now, greater than equal to 30 is a good rule of thumb. Then we have the standard error of the mean, and then the larger samples give smaller standard errors, meaning the sample mean is closer to the true population mean. For example, if we're studying average blood pressure in a city, we don't need to measure every single person. We need to take a random sample of 100 people, and the CLT, or the central limit theorem, tells us that their mean blood pressure is likely very close to the true population mean. So today was a short one, but it's very important. The importance of central limit theorem and why it's the foundation of statistical inference. We learned about that. We also learned about the implications for sampling and how it applies to make predictions about populations using sample data. The central limit theorem is one of the most powerful ideas in statistics, making it possible to analyze small samples and draw conclusions about entire populations. Okay, great. Thank you for watching. We'll see you in the next video.